We've talked a lot about audio in terms of how sound works, how microphones work, and we're not done yet. We need to talk a little bit about how digital audio works, how we take this analog phenomenon that is sound and convert it into the digital realm. You'll recall that when we're measuring sound, there's two things we pay attention to. The frequency of the waves, which our hearing perceives as pitch, and the amplitude of the waves, which our hearing perceives as volume. We measure frequency in terms of hertz and amplitude in terms of decibels. Moving into the digital realm, this changes a little bit. We want to take this analog wave and digitally reproduce it, which means we're going to take measurements at various points along the wave so that we can reproduce the values at a certain time. So if we take a look at this simple wave and we measure it once, you can see I've put a little X there on the one spot on the wave we're going to measure, and then we're going to use our digital technology to reproduce that measurement. The digital reproduction doesn't look much like the original waveform, does it? Not at all. Let's try measuring it in two places. Well, that's a little bit better. It kind of represents the wave in the fact that there's a up and a down, but really it doesn't look much like the wave at all yet. Let's try it a little more often. Let's measure it 9 times and see what happens. Okay, now we can kind of see the shape starting to emerge. Let's try this again. Let's measure it 29 times. Now we're starting to get somewhere. This series of measurements is beginning to have the same shape as the wave did originally. So you can see that the more measurements we take, the more accurate our digital representation is going to be. It's never going to be completely perfect, but it can be awfully close. Each of these measurements is called a sample, and the number of times that we sample is called the sample rate. Now, we're doing this the same way that we do frequency. We're going to measure it in terms of how many times per second do we take a sample. And that, as we did earlier, is measured in hertz. You see a couple of standards there. CD quality audio is sampled at 44.1 kilohertz, or 44,100 times per second. The standard for digital audio, or the audio that's attached to digital video, is 48 kilohertz, 48,000 times per second. We measure the sound wave. It might occur to you to wonder why these numbers exist. Why 44.1 kilohertz? Why 48 kilohertz? Why are these standard? This has to do with something called the Nyquist theorem. This is based on the work of Harry Nyquist, who's an engineer, a physicist. What he noted was that in order to get a remotely accurate sample of a waveform using a digital measurement, you had to take at least 2 measurements. All right, so just like we looked at earlier, when we only took one measurement of our wave, the resulting digital playback had basically nothing in common with the original wave. When we took 2 measurements, at least it kind of looked like the wave. I mean, there was an up and there was a down. The shape was completely wrong, but with a little bit of imagination, and maybe if your eyes were really blurry, you could see how that one would resemble the other. So in order to replicate that simple wave, we had to measure it at least twice. More measurements were better. Definitely more measurements were better, but we had to measure it at least twice. So this is what the Nyquist theorem tells us. Your sampling rate has to be at least twice as fast as the highest frequency that you want to reproduce. You certainly recall from our earlier videos that the range of human hearing at its best is from 20 hertz to 20 kilohertz. So if you want to digitally reproduce a sound as high-pitched as 20 kilohertz, you have to sample it at least twice as much as that. So you have to sample it at least 40 kilohertz. The 44.1 kilohertz for CD audio and the 48 kilohertz for digital video audio both exceed that by a little bit. And there's some engineering and some acoustic theory there that I'm not completely able to understand. But you understand where it comes from, right? To get something in the 20 kilohertz range, frequency-wise, you have to sample it at least 40 kilohertz. So sample rate talks about how often we measure it, how many times going down the time axis we slice it up and take a measurement. But it does not talk about how much information we use to store that measurement. That is called bit depth. And it's literally how many bits of computer storage do we assign to that one sample. It can be a small number, a large number, anything in between. Every bit allows us to have two values. A bit can only be on or off, so 0 or 1. But as you multiply bits, right, it goes up exponentially. So with 2 bits of storage, we have 4 possible combinations, 4 possible levels that we can measure. And you can see on the graph here that with 2-bit audio, we don't really get a very good representation. Even with a high sample rate, if we're only using 2 bits to record each of those samples, our playback is not going to have much in common with the original waveform. The more bits we use to store that information, the more accurate our waveform representation becomes. And very quickly, the larger the file gets as well. So you can see that just going from 2-bit audio to 4-bit audio really made a difference in terms of our vertical resolution there. The standard that we're worried about working with digital video and the audio that goes with digital video is 16-bit. Now, you can get things that are much higher. Our cameras here will run as high as 24-bit, for example. But 16-bit is the standard. With 16-bit audio, we have 65,500 and some odd possible values that we can record. It's a very robust number. When you're working with digital audio workstations or digital audio recorders or even nice digital audio software, it's easy to find that these are minimums. The 48 kilohertz, 16 bits that's standard for digital video is actually on the low end of the resolution these days. I've got a Tascam recorder that records at 96 kilohertz and 24-bit depth. You don't really need it for what we're doing anyway. We don't need to be able to reproduce sounds that humans can't hear, which was what the higher sample rate would do. And there's a certain limit to how accurate your ears are. So having 24-bit depth doesn't necessarily mean it's going to sound any better to your ears. It does mean that it will survive manipulation better, though. So if you're going into a project where you know you're going to be working the audio heavily, maybe doing slow motion video and you're bringing the audio along with it, maybe you're doing some sort of special effects for a demonic possession, whatever, if you know that you're going to be manipulating the audio heavily, it might be a good idea to use higher sampling rates and higher bit depth. But 48 kilohertz, 16-bit audio is the standard for digital audio as it's attached to digital video. Things to take away. Remember that we have 2 different ways of measuring how we digitize audio. The sample rate talks about how often we take measurements. The bit depth talks about how much information we use to store those measurements. Remember the commonly used audio standards that we talked about. 44.1 kilohertz for CD quality audio, 48 kilohertz for digital video audio, both of them at 16 bits. And remember Nyquist and how you have to sample an audio waveform at least twice in order to be able to even barely represent it. So your sample rate should always be twice the frequency that you want to reproduce.